All right, so electromagnetic radiation, what does this actually mean? Well, the following: a kind of radiation that includes visible light, radio waves, gamma rays, and X rays, in which electric and magnetic fields vary simultaneously. So, again, we talked about that word simultaneously means at the same time. Okay. So obviously this is just some type of radiation. This is not all types of the electromagnetic spectrum. If you go to page 2, you'll see that beautiful diagram clearly labeled the electromagnetic spectrum, and that'll actually give you all kinds of radiation that the EM waves produce. Okay, I kind of talked about this yesterday. Our propagation of the wave is this way. And then we have a magnetic field that moves up and down. It flip-flops periodically. Likewise, the electric field is simultaneously flip-flopping back and forth. And this is what your EM waves are kind of made up of. So if you recall, between the electric field and magnetic field, they are 90 degrees apart from each other. Okay? Electromagnetic, why do I keep saying that wrong? Electromagnetic waves move at the speed of light. And if you remember, you can find this on page 1. The speed of light, c, is represented by the value 3 times 10 to the 8 meters per second in a vacuum. Okay, please keep that in mind. In a vacuum. So that means in space only. Okay, that's what that's indicating. So, kind of going through the motions, we're going to talk about this next phenomena called polarization. So, if you've ever heard of polarized sunglasses, well, this is it. So, what polarization is? Well, it's just a cancellation. Let me get my words straight. Cancellation of light due to the orientation of the slits, right? So, vertical light is going to pass through vertical slits. However, it'll be canceled out by horizontal ones. And likewise, if you have horizontal light passing through a horizontal slit and you say, all right, I'm going to add another slit that is vertical, it is going to cancel out that horizontal light because it is that vertical slit is clearly a different orientation compared to the horizontal one. So for example, look at this picture. There is a light beam. Notice that you have this direction, the yellow, and then you also have this blue direction, right? So you have two directions of light. You put in a polarizer, right? This one is vertical because we said that if vertical light can pass through vertical slits. However, if it is vertical, this polarizer, notice what type of light comes out. Well, only the vertical one because the horizontal light here, right? So the horizontal light was canceled out due to that vertical slit. Okay. So again, if you've ever bought sunglasses, usually like anything that's like $20 or more, they're probably polarized. So like I bought a pair off Amazon for like 12, $13. Really great sunglasses. And they actually were polarized. I was a little surprised at that. But if you take a polarized lens and you go towards your phone and you change the orientation 90 degrees, you should actually see your screen darken. And it's actually a really cool experiment. Okay. Right here, it's the same thing with sunglasses, right? We just spoke about that. So clearly we have two different orientations of waves, the red one and the blue one, okay? So what ends up happening, you put your sunglasses on. Now that is preventing the horizontal light from getting through into your eyes. Notice that there's no red line coming in. There's only the blue ones, which means that only vertical light can go in because it's a vertical slit. Whatever the lens is, it's a vertical slit and it is canceling out horizontal light. Okay? So, a really good way to remember this, and I thought this was a very cute example. I think if I was in high school and I learned it like this, it would have been really helpful for me. But we use a picket fence analogy. So, when the pickets of both fences are aligned in the vertical direction, a vertical vibration can make it through the fences, right? So we know like we're just going through the fence and because they're both vertical, right? And vertical means this direction. So it allows vertical light to pass through. However, if I were to change the orientation, right, I go, all right, so this is a vertical slit, but then I have a horizontal one, it doesn't let me pass anymore. And I can't get through, right? I'm not going to have any more waves come through anymore. So that means with this horizontal slit, the vertical light is blocked right? So if you're getting canceled out, that means that you have the opposite orientation slit there. So vertical light will be canceled out due to horizontal slit, and horizontal light will be canceled out due to vertical slit. Okay, so I think this is a really kind of cute way to remember, hey, like that's what polarization is. When one orientation of light is getting canceled out because the opposite orientation slit is put in the lens. Okay, so let's do an example. The diagram shows sunglasses being used to eliminate glare. Which phenomenon of light is represented in the diagram? So you have the sun, right? Wee, beautiful. And then you have light. And then there's this symbol. And then there's this pair of sunglasses right here. And then they say, okay, this is the light now. What does that mean, right? So these are all the different possible directions that my light wave could have came in at, okay? And then I put on the sunglasses and I only have the vertical. Well, it's certainly not dispersion, we didn't learn it yet. Certainly not internal reflection, we didn't learn it yet. Can't be diffraction because this is the bending or spreading out of light, and that's clearly not what's happening here. So the only answer that we know to be true is polarization, okay? So that's pretty much as hard as it gets for polarization. You just need to understand that light is going to get canceled out. So I'll put VL as vertical light. So if it gets canceled out, that means you have a horizontal polarizer. Likewise, if you have horizontal light, that means that you were getting blocked out because of a vertical polarizer. Okay, so whatever form of light is not getting through, it's because the opposite orientation slit is being used. Okay, and it's only allowing that specific orientation of light to get through. So if it's the opposite orientation, it is certainly not going to be able to come through. Okay.